Hello dear students, welcome back to channel Chemistry Concepts by Samin Mumtaz. Today we are going to discuss how to describe and explain diffusion in terms of kinetic particle theory. Diffusion is the process by which particles, atoms, molecules, or ions, move from an area of higher concentration to an area of lower concentration. It can be explained in terms of the kinetic particle theory, which provides insights into the behavior of particles in matter. In a system at a given temperature, particles are in constant, random motion. They possess kinetic energy, which drives their movement. This motion results from the constant collisions and interactions between particles. For understanding we discussed: Number 1. Particle motion. Number 2. Collision and interaction. Number 3. Concentration gradient. Number 4. Net movement. Number 5. Equilibrium. Number 6. Factors affecting diffusion. Particle motion. We know that according to the kinetic particle theory, all particles in a substance are constantly moving. This motion is influenced by their kinetic energy, which is directly related to temperature. The higher the temperature, the more kinetic energy the particles have, and the faster they move. Collision and interaction. As these particles move, they collide with each other and interact. These collisions are elastic, meaning that no energy is lost during the collisions. When particles collide, they transfer kinetic energy and momentum, leading to changes in their speed and direction. Concentration gradient. Diffusion occurs when there is a difference in the concentration of particles within a system. Particles naturally move from regions of higher concentration to regions of lower concentration. This is due to the randomness of their motion. Net movement. While particles are moving in all directions, the net movement of particles from an area of higher concentration to an area of lower concentration leads to the process we recognize as diffusion. This net movement occurs because, statistically, more particles are likely to move toward regions with lower particle density. Equilibrium. Over time, as diffusion continues, the concentration of particles tends to even out within a system. This leads to the establishment of equilibrium, where there is no net movement of particles because the concentrations are equal. Factors affecting diffusion. Several factors can influence the rate of diffusion, including temperature. Higher temperatures lead to faster diffusion due to increased particle speed. The size and mass of the particles. Smaller, lighter particles diffuse more quickly, and the presence of a barrier or medium through which diffusion occurs, for example, a porous membrane. So diffusion is a natural consequence of the constant, random motion of particles described by the kinetic particle theory. It's a process where particles move from areas of higher concentration to areas of lower concentration until equilibrium is reached. Understanding diffusion is essential in various scientific fields, from biology, for example, gas exchange in cells, to chemistry, for example, mixing of reactants in a solution, and beyond. Thanks for watching. In next video we will be describe and explain the effect of relative molecular mass on the rate of diffusion of gases. Thank you.